Hey guys, Flight Sim Jammer here, and have a different project for you today. We are modifying and building essentially from scratch a TPM throttle mixture prop quadrant, for lack of better terms. The original one, so this is the original knob and push button and bearing and stuff that I got off of, I believe, Thingiverse, one of the places you can get 3D printed STL files from. This one is Cadet's Cadet standalone mixture knob. And the thing that's cool about this is, let me just take this off because it needs to come off anyway. If you look, when you twist it, it's going in. If you watch the sleeve to that, the sleeve isn't normally there. It's just there when I take this off. It stops the bearing from shooting out. Well, when you get the file off of Thingiverse or wherever, it normally comes with this sleeve. And the issue with this sleeve, I'll show you the difference actually since they're in my hand. If you look, I needed 20 millimeters more threading than what this one had, because in the original sim, the metal of the dash is approximately 16th inch. I don't know the exact measurement. The dash in this sim is 3/4 of an inch. And so here's the issue. If you look at the new throttle panel that I built, if that was through and this was the only part, then you could almost get a nut on there and it would hold. But if you can tell, it's just barely even enough room. Well, I could make that work if I had to. However, see if I can hold this. These are all still soldered together from the other sim. This has to go through that. And then if you can imagine, well, I might be able to do it. It doesn't even stick through. So the sheath has to be on there because it goes through and you have your potentiometers in there. And you can see I had to cut this one to even fit in the other sim. Well, one would think that it would be super easy. You just throw this in your 3D software and extend the nose out 20 millimeters and everything would be perfect. That is not the case. I spent 3 days trying to figure it out, and I'll tell you why. Making this part, this is super easy, really. The hard part is inside the hole there. There's no way we'll see it, but I'll go in and see. No, camera won't focus. Inside these tubes is a groove. And without knowing what the thread pitch is, like this is an M14 175, 125, I have it written down, which this nut will thread onto. That was easy to do. I went and got I got my tap set that just happened to have one this big and it fit on there. And the threads inside, I couldn't tell what they were. So I went through almost a quarter bag full of prints trying to figure out what the threading is. So now that I have it figured out and it works, so the big thing was the bearing wouldn't lock into the threads, and if it doesn't lock into the threads, then there's no point in having it adjust like this. After 3 days, 4 days, whatever it was, I finally figured it out. And what I'm going to do is show you how to make it in 3D, how to model it, and then if you guys want to make one for yourselves and you have your own 3D software, you can do it. You can download the one on Thingiverse, but this is just the basics behind doing it. So give me a second while I switch screens here. So here we are. This is Fusion 360. And the very first thing that you should do is click save. And actually, if you notice, see this little asterisk star looking guy? That means that you have not saved the file yet. You notice this one doesn't have it. So save. And you can put stuff in there if you want. I've never have, but see now there's a check mark and now it is saved. So I'm gonna jump back to my webcam and show you my rough drawing here. And so I have a rough drawing of what it looks like. And if you notice, it's only half of the shape. And I will show you why here in a second. So the other thing I can show you, obviously, I have two files here. And this one, I have it all laid out. This is what we are going to do. You can see I've had to do a lot to get it to this point. So the first thing that we want to do after we have saved, and your save name will come up here in your main save folder, we want to create a new component. That component we are going to call sleeve. Actually, we'll call it mixture sleeve. And we don't have anything built, so we don't want from bodies, but we do want it to say activate. And its parent is this right here. All right. So now anything that is in here, we can turn this origin on, we can turn that one off. Anything that is in that we do right here is going to be part of the mixture sleeve. If we needed to build another part, say the nut for it, then we would go ahead and do that as a new component. We want to go sketch, and because of what we're going to do, we want the side profile of what we're making. Okay, so we click that axis, and we know it's that one when we get to the front. And we always start on the line. And our first measurement was 5 millimeters. You could do all this in inches. I found that even in like the slicer programs and whatever, everything was in metric. And it was, Fusion can do the measurements and calculations for you. I thought it was easier to just switch and learn metric, and now I can get stuff down to a whole millimeter, so for me, much better. All right. This one here was 65, and we're just gonna put it up. We'll go up 4. Well, 65 and 4 degrees, because we want it to be a little bit thicker as we go. Now we can go 2 millimeters, and I did 45 degrees on that one. And this one was 5 millimeters and 0 degrees. Didn't actually stick. 5 millimeters. There we go. And this one was 3 millimeters. I didn't mean to hit enter. This one was 20. 20 and 0. And this one, that's better. Down and lock. And there. Okay. So as you can see, we have our cute little half of our sheath that we were building. And so now we might have to change it out a little bit, but now what we do is we hit finish sketch. And the reason that we did half of it like this is because if you hit revolve and you select it and you select that line, look, super easy. There's our main shape. Then, so the threading on the outside, we're gonna jump back over here real quick and throttle shaft, bodies, that's one. We have M14 by 125. And it is as easy, it should be as easy as going thread and clicking here. M14, 125. Make sure you click model and click OK. And it changed the shape or the size of it to exactly what we needed. Okay. Now, that's good. That's good. Oh, we want to do one more thing here. We want to, right on this guy, create a point right in the center. Finish sketch. And bring it back up. The reason we want to do that is we need a hole that goes all the way through. As you can see, it goes all the way through. And a simple hole tap type, which is just no threading. And we want it 6.1. And when you're done, look, you have this beautiful sheath. Now, if you didn't want to have the ball bearing to lock into threads and stuff, you could stop right here. You could make yourself a nut and give it the threads inside. It'll screw on and you are good to go. I, however, wanted it to work how it was supposed to. So I might have to jump out real quick. What I'm about to show you I made that part that fast the first day. The next 3 days was trying to figure out exactly what threading was inside here. So I went through making coils, I went through making threads, I went through trying to sweep it, and actually, let's go back here real quick and turn. Okay, it still was a coil. That's what we ended up doing. Create coil. .2. Okay, let me show you this real quick. If you notice, that is going to create threads from there back. And in reality, that is probably fine. However, If you want to create them from the very front, do a construction plane. Do it on the nose of this guy. And you don't want it exactly on the front, because then there's a chance your ball bearing will come out. So I would go in at least a millimeter. I'm going to do 1 point. Oh, make sure that you do the negative if it needs to go backwards. Negative 1.5. Okay. So now when we create coil, we click that one on our center point, 6.2. Don't worry that it's going the wrong way. Grab it. In theory, you should be able to grab it and pull it backwards, like that. And there's all these numbers over here, and it looks so super confusing, right? Don't let it confuse you. We want to go to height and pitch, 6.2 millimeters, which is the height of the hole that it is cutting. Our pitch, we want our pitch, I'll tell you height in 1 second. Our pitch is 2.288. Our height is different on this one, but 90, so let's go 88. And that will do the same thing. That will cut it to where, if you notice, it stops inside of it. So the bearing, when you're spinning it at least, can't come out. No angle. We want section circular, section position on center, the section size, 2.1, and then cut. Click OK. Now, let me go back in there and explain, because I went through it really fast. This allows you to say height and pitch. The other ones you can say how many revolutions in height, how many revolutions in pitch and spiral. Okay. This, like I said, is the size up and down of the hole. This height, which you would think is how tall it is, but it's not. It's how long you want it to go in the tube. So you do minus and whatever number it takes to get however far you want those threads. The angle is the angle of the threads, and I want mine straight up and down. This, you can change it to a square hole. You can change it to triangle size hole, but the original use, the circle one, I actually cut it in half so I could see inside of it. And then you have section size. This part on center, inside and outside, not 100% sure what that was. I didn't play with it. But the section size. Now, we have 2.1 there, and I will show you, I'll show you what it is. So we go inspect in section analysis and click here. We can cut this baby right in half, okay? Don't worry, it's not gone forever. You come down here, you open this. Oh, nope, construction, sorry, ha ha ha. Go to analysis and you can turn it off. It didn't actually do anything except make it to where you can come in here. That 2.1 is the distance between here and here. I can't click on it because of how it cuts it out. And if you look this way, you can see that would allow the ball bearing to sit down inside of this just enough. The ball bearing is 3 millimeters, so it won't go all the way down, and it shouldn't, because then it would just fall into it. You want it to create pressure against it. And so, yeah, 2.1 there. And when you turn the mixture knob, the ball bearing will follow itself right down in there. Now, that right there, my Flight Sim Jammer crew, that is the whole thing. The big thing you want to do is make sure that you save, because you don't want to lose your work, right? Now, I can see that I've been recording now for 27 minutes. So, the first time, it took me 3 days, 3 hard crunching days. When I say days, I mean I worked on it for 6-8 hours and printed a quarter to a half spool of parts. And I also did the same thing with the throttle, and you do the throttle the same way. But in the parts, I can show you a couple here. Let me jump back to the cam view real quick. In the parts, hopefully it shows up. You can see I printed a whole bunch of thread patterns. This is actually how I figured out what size it needed to be. This was on day 3. I was like, why am I not just printing out little chunks of threading and seeing which one the ball fits in? The first thing I was doing is just little sleeves, and I would do the numbers, and then I would print it out, slip it on. That's like one of the sleeves. It's exactly this sleeve. This is the one that fit almost perfect, but not quite. And so I use that now when I pull this off, like I said, to catch the ball bearing. Well, this one actually, if you look at it really close, you can kind of see that it's actually threaded. That's how I started figuring out the threading, because you don't want to print this whole sleeve, so you export it and you cut it in your slicer about, yay, and just print the little chunks. Anyhow, this is how I did the throttle one. You can see the throttle has that cut through it. You make it exactly the same way, and then you make a rectangle that is 2 millimeters high, and this is 8 millimeters, so I did 10 for the rectangle, cut it down to that flat face, and that creates the pinch. When the throttle is in there and you tighten down the nut, it gives it just enough pinch on it to hold it. So yeah. Now, what do you do from here? You go, after you've saved it, you go File, 3D Print, click on it. I always hit Preview, and I do that so sometimes not all of the model gets clicked. And let's just make sure it does. And then you hit OK. And you name it whatever you want. You see TPM Rebuild, and I was calling them test panels, whatever. And here you can click on it, and this will show you, well, actually, here, I'll show you, actually, this is a good way to show you. These are the end ones, and these are all of the ones that I went through to try to figure it out. Looks like 18 there when I started numbering them, plus some that aren't numbered. Anyway, you name it, just do it YouTube Sheath, and click Save, and it's YouTube Sheath, save, and that just exported as an STL that you can put in your favorite slicer. We have a Bamboo Labs. This is the throttle one, and let's see. we'll just throw it in just so you can see. Bottle. Oh, did it go in here? It did. That's okay. So you find it and you put it there. Auto rotate. If you notice, this one prints on its head and around the threads, which is totally fine. You absolutely want to have supports. And when you click slice, pull this guy over here, you can see you got all these tree supports. Prints it, holds it. Take 50 minutes and 4 seconds to print that. Obviously, I'm not going to do it because I have already done it. I will throw up some B-roll of it printing because the Bamboo Labs P1S does time lapse, and you guys can watch it if you want. So I hope you guys enjoyed that. I hope it's informational. That is probably my third video that I've done on the Fusion 360. I'm not the very best at it, but you know, this hobby is all about learning and building and creating. And there is some people that would just rather buy it, and you can totally buy a TPM setup. As a matter of fact, Honeycomb has one out now, and I think it's called the Delta. Haven't really looked into it. $600 and it's done. Bolt it in and go. If you have a 3D printer and you like doing stuff like this, a whole spool of filament costs, well, we'll say $15, $15, $20, depends on what you get. And we have Sunlu. It's the cheaper stuff. It works great. And it maybe took a quarter roll to print everything for it, including the new faceplates. So you call that, let's just call it $5. It's not $5, but we'll call it $5. And you have $10 worth of slide potentiometers and a Arduino Leonardo, and that is $20. So, and then some nuts and bolts. Let's say under $50, way under $50, you could build yourself a TPM setup. Because all these knobs are 3D printed, the sleeves are 3D printed. These metal pieces, these are actually drinking straws that came from the online, 2-day shipping store. And that's one of the hard parts, is drilling the hole. But follow the cadet guys' information. Don't quote me, I think it's 94.8, 94.6, 94.5 millimeters from the end of the straw to where you drill the hole. You got to have a brand new drill bit and go really slow, otherwise you warp it, because these are stainless steel. The thing that I really like about it is it gives it a real airplane feel, because when you're pulling it out, it's never going to be out this far from the end. I think it comes out like that far, and then you have your nut to hold it on, and essentially you want it out far enough that your hand can hold it, and it's more than sturdy enough. So anyway, hope you enjoyed this video, and if you like this kind of content, let me know. We can work on trying to do more of it. And yeah, we have to build a new panel to hold all the radios in this sim. And we have to build a switch panel, because the one I had built for the big sim doesn't fit in here. And another project is the gauges in here. I wish I could turn it and show you. They have all rotary encoder knobs, and those are going to get wired to a Arduino Micro Pro, which will plug into the computer, and the computer will think it's a joystick, and you can set what you want them to do without having another program running like MobiFlight or something like that. So stick around for those videos. They'll be coming out soon, hopefully. Yeah, well, I hope you guys have a great day. Please like and subscribe and share the channel. You guys are keeping me going. It's amazing. Huge thank you to all of you for all you do. You guys have a great day, and remember, land safely.